Okay, ladies and gentlemen, we're going to do a test review. This is basically questions from previous examinations. And the first thing we're going to start with is Doppler effect and sound and loudness and things like that. So, part A, wavelength of a wave with this frequency and 343 meters per second. So velocity is wavelength times frequency, which means wavelength is velocity over frequency. Well, that's just 343 over 545. So let's get the calculator out. 343 divided by 545 equals wavelength 0.629 meters. Velocity is in meters per second. Frequency is in hertz, which is an inverse second. By the way, just take a note of that. And of course, we talked about that in class. Sound intensity, 1 meter from the source. We're told the decibels at 1 meter is this. Decibels equals 10 logarithm base 10 over intensity over the reference intensity. The reference intensity being 10 to the negative 12 watts per meter squared. Inverting, they want to know what's the sound intensity at 1 meter. Intensity, I'll call it 1 for 1 meter, equals the reference intensity times 10 raised to the beta divided by 10. Let's go to our calculator. Now we can plug and chug. Where'd my calculator go? There it is. Okay. Beta over 10, 100 decibels divided by 10 equals this, and take the raise it to the 10th power equals, and convert it 1 times 10 to the 9th. That's right. 100. Wait a minute. That's not right. What did I divide by 10 for? Take a look in my history. Okay. Clear. 100 divided by 10. So beta over 10 equals 10 to the x. And hit that. Yes, good. I shouldn't have, I don't know how that division by 10 came in there, but 10 to the 10th, that's correct. Times 1 times 10 to the negative 12 equals 10 to the negative 2. Watts per meter squared. Part C. 27 meters from the source. What is the sound intensity? Well, I1 over, this is the inverse squared law, ladies and gentlemen, is going to be the distance squared 27 at 27 meters divided by the distance squared at 1 meter. Inverse squared. They're inversely related. I set this up as an inverse proportion to the distance squared. Okay, solving for I-27 equals the intensity at 1 meter times radius at 1 meter squared, which of course is 1, radius of 27 meters squared, which of course is 27 squared. Plugging and chugging into the calculator. 1 divided by 27 square it equals, and then multiply it, times 10 to the negative 2. 1. I get 10 to the negative 5th. 1.37 times 10 to the negative 5th watts per meter squared. Okay, D. Now, convert it back to decibels. We've already got the equation, and we've got the intensity right there. So it's just plugging and chugging. Oops, come back, calculator. Where'd the calculator go? There we go. There's the calculator. So it's divide this by the reference intensity, 10 to the negative fifth divided by 10 to the negative 12th. Take the log base 10 of this. Where is my log base 10? There it is. Log base 10 of this. And multiply it by 10. So it should be 71.4 decibels. And yeah, 71.4 decibels. Okay. Finally, E. This is a Doppler question. Frequency over the original frequency, the starting frequency, is 1 plus or minus. This is the velocity of the observer over velocity of sound divided by 1 plus or minus velocity of the emitter over the velocity of sound. And remember, if it's approaching, if it's getting closer, frequency goes up. So plus if approaching, negative on the top if receding, going away. On the bottom, it's just flip-flopped. If the denominator goes down, the frequency goes up. That means it's approaching. So it's negative if approaching. And positive if receding. Um, 24 meters a second. The sound source, VE, is 24 meters a second. That's the emitter, sound source. The velocity of the observer is 0, so the numerator is just 1. So the frequency observed equals the original frequency times 1 over the sound source is approaching, so it's higher. 1 minus sound source, 24 meters per second, divided by the velocity of sound, 343. Now it's just plug and chug. Go back to the calculator. 545 hertz. The original frequency is 545. Okay. So we get 24 meters a second. 24 divided by 343 equals, negate it, add it to 1, equals, now I got to take the reciprocal, equals, something's wrong, clear everything out, 1 minus 24 divided by 343 equals, there we go. That's the denominator. Get the reciprocal. Multiply it by 545, the original frequency, equals. So I get 586. I'm gonna check my answer just real quick. Yes, I did 1 minus 24 over 343. I took the reciprocal and multiplied by 545. Okay, goes up, just what you expect. Voila, we're done. This problem is completed.